Constraints are objects that enforce data integrity. Now, since there's different types of integrity, they've invented different types of constraints. We've used several of them already. Here's an example. You may remember that the intersection of a row and a column is a cell that has a single value, and right here we see the number 68. Now, just looking at that one domain value and not looking at anything else, we know that landmass for any value cannot be a negative number. Just looking at that proposed value, we can say yes or no as to whether it's valid. Therefore, this check constraint is performing what's known as domain integrity. When you're making data changes to a field that has a constraint, it's going to check to see if that is a valid value. So what other kind of integrity could there be? Well, then here's a question. Would this be a proper ID for the state ID field? Capital T, capital U. And the answer is, you don't know that yet until you look at all of the records of the state ID field to see if TU is already present. Just looking at the proposed value is not enough to know whether this is acceptable. You've got to cover all the entities or rows of the table and look for other values. Therefore, primary keys and unique constraints enforce what is known as entity integrity. With entity integrity, SQL Server not only looks at the proposed value, but looks at other values in the same field to see if that value already exists. There's still one other type of integrity to discuss, and that is this. Let's look at the location ID for David Lonning. We know location 1 is valid. How about if we want to update this to location 9? Would that be okay? How do we find out if 9 is a valid location? Well, we're actually going to have to look for a value in a different table. We're going to look for the value in the location table. Since 9 is not listed in the location table, we want to disallow the update to location 9 for the insertion for any of the employees. The process where a constraint must look for an existing value in a referencing field, usually in another table, before it validates it, is known as referential integrity. So how easy is it to accidentally violate referential integrity? Well, the answer is pretty easy until you implement what's known as a foreign key constraint. Foreign key constraints ensure referential integrity is in place. Now let's try to put in an 18th employee, and let's try to give them manager ID 11, which is fine, but accidentally put 11 in for the location ID field, which is not fine because there is no location 11. So let's go insert into employee the following values. Employee 18 will be Kim Rowe, and we'll put in the current timestamp for her hire date, and we're going to put location 11 as well as manager 11. It's easy to get those confused. And we'll add the 3 defaults in from the last lab. Okay, is it going to accept this location? It says 1 row affected. Go to the employee table, and we can see it accepted location ID 11. Oopsie. Well, let's fix this. Let's go ahead and delete this employee and reinsert them later. Let's go ahead and delete employee number 18. Okay, referential integrity is back, but our new employee is gone. So how do we make it so it won't accept that type of insert from anybody again? We're going to alter the table employee, and since this constraint is a foreign key, we will name it FK underscore employee underscore location underscore location ID. Now what this means is the employee table is going to look in the location table on the location ID field for an existence of a record before allowing the record to be updated in the employee table. And we're going to say this is a foreign key on the location ID of the employee table that will reference the location table's location ID. All right, let's run this statement. It says commands completed successfully. Now, when you attempt to insert location 11 for Kim Rowe, it'll say, okay, you can't insert it because it conflicted with this foreign key on the JProCode database, in the location table's location ID column for the employee table. With our new foreign key establishing referential integrity on the location ID field, we feel a little safer about only valid inserts making it into our table. So let's do the insert into employee, the following values. Let's do 18, which is Kim Rowe. And let's say current timestamp. We'll give her location 1 since that's valid. Now most people get manager 11, but look at this typo. Is there any employee in this small company with an ID of 111? No. But do you think that's going to stop us? Not unless we set up another foreign key. So let's go ahead and run this. And it says 1 row affected. You know what that means? Let's open a new query window and look by typing select star from employee. And let's scroll to the bottom, and it looks like Kim works for manager number 111. But there's only 18 people working in this company. Well, let's create the foreign key to protect the manager ID to be a valid value. So let's go alter, table, employee, and we're going to add a constraint called fkey_employee, which will also refer to the employee table, and we'll call it manager ID. Now this foreign key will be on the manager ID field of the employee table, because that's the one it's going to prevent from having invalid values, and it will base it on its reference to the employee table's emp ID field. Let's go ahead and run that. And it says, you know what? I cannot make this foreign key because I have discovered there is already a record that conflicts with this foreign key. So usually you want to go clean things up and then protect your data. But what if you're afraid that by taking that time and waiting, more bad records are going to be coming in, and you'll have this constant battle? Could you protect it and lock it down and say, okay, ignore existing violators, just prevent more from coming in. I'll go clean up the violators later. You can do this by specifying with no check. Now let's run this. There, we've locked it down. Now we can go ahead and change the ones that don't have referential integrity, and we have achieved the fact that we're ensuring that no new violations will be coming in. Currently, the only record violating referential integrity is Kim Rowe, and instead of updating her, let's get rid of her. Let's say this was just a test record. There is no Kim Rowe. Let's simply go delete from employee where emp ID equals 18. Let's run that. 1 row affected. And let's look at our employees. We should only have 17 of them. 17 records. Last one is Wendy Downs. No more Kim Rowe. Check constraints usually do domain integrity, but they can also do referential integrity. For example, we can see that January 11th, 2006 is a valid date. Well, how about May 11th, 2005? Is that a valid date? Well, we don't know that until we look at when it was ordered. We have to look at another value in another field, and we see that this was ordered on January 3rd. Well, there's no way you could have paid for it before you ordered it. Therefore, you can have a check constraint look at another value within the table, and therefore it would perform referential integrity. Let's recap the 3 types of data integrity. The first one is the simplest, domain integrity. Based on the proposed value, the constraint allows or denies the DML statement to run. It doesn't have to look any further than the value coming in. The next type of integrity is entity integrity. Based on the proposed value, SQL looks at all other entities within the table. For example, maybe you can't have 2 employee 7s, so it looks at value 7. It looks in the table to see if there's already employee 7, and then it will say yes or no. So primary keys and unique constraints do entity integrity. And finally, there's referential integrity. Based on the proposed value, SQL looks at another existing value in another column, like another table. For example, you want to hire a new employee and say they work at location 10. Well, you can't tell by looking in the employee table if that's valid. You've got to go to another table, the location table, and see if location ID 10 exists. If it does, then allow it. If not, then don't. Foreign keys enforce referential integrity. Lab 1.4, Skill Check 1. Create a foreign key relationship called FK_grant_employee_empid that ensures all empid values entered into the grant table are from valid values listed in the employee table. Skill Check 2. You notice that your invoice numbers range from 1 to 1885. Someone entered a record into the sales invoice detail table referring to invoice 2000. Tomorrow you will investigate what to do with that record. In the meanwhile, establish referential integrity between sales invoice and sales invoice detail so that only invoice ID values listed in the sales invoice table will be allowed into the sales invoice detail table. Skill Check 3. Add a foreign key so the product ID field of the sales invoice detail table references the product ID of the current products table.